Hello, everyone, and welcome to our webinar today on what's new in Java 16. Before we start, we do have a few quick announcements that we want to make. First, 1 week from today, April 22nd, is the third annual Tech Skills Day. Pluralsight will be celebrating with a live stream featuring some of the foremost experts in software development, data science, security, and education. You can visit techskillsday.com for more info on how to register for this free event, and we hope to see you there. Secondly, there is still time to take advantage of Pluralsight's free April campaign to get free access to over 7,000 courses, learning paths, skill assessments, and more. To sign up with no credit card or payment info required, please visit pluralsight.com/freeApril. Please just visit pluralsight.com and then you'll see a banner on the top of the page. Finally, this webinar is being recorded. If you're watching via Zoom, an on-demand version will be sent straight to the email that you registered with. You can also watch on Pluralsight's Twitter or Facebook account and view a recording of the event immediately afterwards. Otherwise, please expect that link in your email inbox. And lastly, before I turn it over to Sander, I want to call out that we will be having a approximately 15-minute Q&A towards the end of this event. So if you have any questions that arise, please put them in the Q&A box at the bottom of your Zoom window, and we will get to as many as we can. And with that, Sander, the time is yours.
All right, thank you. Hi, everyone, and thank you so much for joining me in this session on what's new in Java 16. My name is Sander Mak, and I'm joining you from the beautiful country of the Netherlands. Hope you're all doing well. And my background has been in Java for over a decade. I've been actively involved in the community there, also as a Pluralsight author, but also writing books for O'Reilly, and in general being involved in the community and following whatever is going on around Java. So that's why in this session, I want to take you on a whirlwind tour of what is new in Java 16. And we'll be looking at some of the highlights because we cannot cover it all in this one session that we have. But before we dive into what is in Java 16, I would really like to set the context a little bit, the context of where we are with Java, because usually people think Java is this slow-moving enterprise language where we get major new releases every 3 or 4 years, and this used to be true. However, as of Java 9 and Java 10 that were released in 2017 and 2018, Java has made a switch to a time-based release schedule where we get a new version of Java every 6 months. So this is also why we're currently at Java 16. And this is something that may surprise you if you've not been following Java very closely. But that's where we are now. So every 6 months we get a new release. Now, Java 11 is somewhat special and was released towards the end of 2018. And we'll talk about why Java 11 is special in that regard in a bit. But this has been going on for quite a while. So that means that we're currently at the first release of 2021, which is Java 16. And later this year, we will be getting Java 17. Now, I already mentioned that Java 11 is somewhat special with respect to the other releases that have been made of Java. And that has everything to do with the level of support for a version of Java. Now, Java 8 has been a long-term supported version by Oracle, and Java 11 is the next long-term supported version. That means that these long-term support versions are actually available for you to use for a longer time than just the 6 months between the releases of other Java versions that we talked about. And after Java 11, the next LTS release will be Java 17. So this means that Java 16 is not such a long-term supported release. However, that doesn't mean it's experimental or that it's not production ready or anything. It is a real Java release with real language features, as we will see. And people definitely have the choice whether to move from LTS to LTS release, so wait 3 years or not, or to hop on the frequent release bandwagon and get a new version of Java and new features and new performance improvements every 6 months. Now, let's not dwell too much on this release schedule, but this is more to give you a bit of context about what is happening in the Java ecosystem. So that being said, for Java 16, what I would like to cover today are these 4 topics. First, I will briefly go over a small enhancement to the Stream API that I think will be very appreciated by many developers. But after that, I won't be focusing on APIs, but I will be focusing on the language itself. So we are going to look at 3 features. The first one being records, the second one being pattern matching, and the last one is actually a preview feature, sealed classes, that is already delivered in Java 16, but that is not yet enabled for production code. But we'll talk about that last. First, let's have a look at what happens to the Stream API. And to already manage your expectations a little bit, there's no complete overhaul. This is just about a small addition to the API that I think will make developers' lives easier. So it's good to know about that. If you work with streams, which were introduced in Java 8, you will probably be familiar with code like this, where we have a stream, in this case, of strings. We map some function over it, then we filter. And in the end, a stream needs to be materialized back into another collection, like, for example, a list. So often our stream pipelines end with this .collect, then passing in a collector, which is usually the collector's toList collector. And if you keep writing this over and over and over, you might start wondering there should be a better way to do this. And indeed, in Java 16, a new shorthand has been introduced in the Stream API, where you can now just say toList on the stream, and you will immediately get back a materialized list from stream. Now, you should be aware that the list that you get back from this method is an unmodifiable list, so you won't be able to add or remove any items from this list anymore, which is usually not a big deal because most of the Java code bases are converging more on immutable data anyway, but it's definitely something to keep in mind when you're using this method. Now, you might also be wondering if there's a toList, is there maybe also a toSet or some other collections that you can materialize into, and that is not the case. So a toList is the only addition here. If you still want to materialize your stream into another collection type or even any other arbitrary type, you will have to pass in a collector to the collect function. Now there's one other addition to the Stream API that I want to mention, but I won't go into the details here because it will be a bit of a stretch in terms of time. But the map multi-method has been added, and it's actually a variant to the flat map method that you might have worked with in the Streams API. And it offers you a way to actually push elements individually to a consumer that you pass to this map multi. So if you're familiar with flat map, I definitely recommend looking also into the documentation of this new map multi method. That being said, this toList is already very convenient to have and is a little small delight that we get when we move to Java 16 in terms of API improvements. But I would like to focus more on the language, as I said. So let's move on to the first big language feature that is being delivered in Java 16, and that is the records feature. Now, I can really say that this is a long anticipated feature. What is it all about? Well, in Java, we often have classes that we only create to just hold some data. And these plain data holders start out as a class, and there we define the fields of this data. And theoretically, this should be enough for us to define the essence of what we want to do. But to get a real working class that contains some data, we obviously need a lot more code in Java. So we would also have to introduce a constructor that takes all the fields and sets them. We need to add getter methods, possibly setter methods if it's a mutable data object. And last, but certainly not least, if you have these kind of data objects and you want to use them maybe as map keys or as in other places where equality of these objects is really important, then you also need to implement equals and hash code, and likely also toString to work on the elements, the data elements that you defined for the class. So this works, but it's a lot of code for essentially a very simple concept. There are some ways around this, of course. Our IDEs are pretty good at generating this kind of code, but code generation has drawbacks. It can get out of sync. There are also some libraries and some tools that help out with this, like, for example, Lombok. But using these kind of tools also has some drawbacks. So essentially what we would like to have is something in the Java platform that offers this kind of functionality. Unfortunately, we get that with records. So with records, this simple data-only class can be expressed as follows. We say public records rather than class, where a record is a special restricted form of a class, where we only need to define the data elements, the components that are part of this record. And we do this immediately after the name of the record. So we call this record product, and we say that a product has a string name in price and a Boolean flag in stock in this case. Now, what we get from this definition is a class that we can use this as a class in our code, because we automatically get a constructor that takes all the component elements that are listed in the definition of the records. We also get automatically equals, hashcode, and toString implementations based again on these components that we defined and their values. And we also get accessor methods for every component in the record. So all in all, this very concise definition gives us a lot of functionality for free. Now, it should be noted that records are actually immutable data classes. So there will be no setters, there will be no mutation of the data. And again, as I said previously, most Java code bases are migrating more and more to this use of immutable data. So in that sense, it really fits with, let's say, the spirit of what is happening in Java code bases. But that's definitely good to know, because you can also view this as somewhat of a restriction. Furthermore, a record definition is always final. It cannot be extended. And also a record itself cannot extend another class or another record. You can implement interfaces with records, but you cannot create hierarchies of them. Now, before we move on to a little demo, I also want to give you a little bit of a mindset about how to think about records. You should really view records as a new restricted form of a class, to just model data as data and not have to deal with everything around it that we saw previously. A little bit like an enum is also a very restricted form of a class. You can also view records as tuples, and many languages have support for tuples, where you just slap some arbitrary elements together and then you can reference them by index. But in Java, we don't usually do this, and in Java, names really matter. So in this case, a record is a tuple where each element of the tuple, each component that we saw, has a real name that you can use and reference. And again, records are immutable. So this should not be used as something for mutable data. It's also good to think a little bit about what records are not and how they're not designed. It is not in principle designed as a generic boilerplate reduction mechanism that should be able to replace any sort of data class that you have in your code with a record. It will only be able to be applied if it fits into the limitations that we talked about. It is also not designed or meant to replace Java beans, you know, the getters and the setters. Of course, because, well, there are no setters, a record is immutable, but also because this Java beans convention is really not something that is baked into the Java language model, and this is not something that they want to do there. So Java beans are an entirely different kind of way of working with data, still valid for some use cases, as we'll see later. But in general, it is not a one-for-one replacement for any Java bean that you have in your code. Last, you might also think about records as value types, where value types are really about very efficient memory layout of data in your classes. This is also something that is in development in Java, but this is not what records are about. Records are really about just modeling data as data and not about efficient memory layouts of these kind of classes. Of course, if value types ever come to Java, then records might definitely be gaining some benefits from that. But it's not currently the case. That being said, we talked a lot about records, so I also want to just show you how they work in practice. And for that, I'm going to switch to IntelliJ. IntelliJ also has support for records already, so that's very convenient. And here you can see that I defined this product record, and just as we saw in the slide, and we can actually start using it. So if I go to my main class, I can easily define a new product, let's say P1, where I say new product, and there you can see that we get this constructor implicitly, and let's create a peanut butter. There we go, and its price is maybe 200 cents. And is it in stock? Yes, it is in stock. There we go. And then I'm going to print this product P1 to the console, just to show you that there's indeed also a really nice toString implementation where we can see the name of the product, the record type, and also the individual components are printed to the console. And what is also interesting to see is that if we look at the auto-completion for the product that we just got, we also see these accessor methods here for in stock, for name, and for price. Now, as I already said, products also get a sane and meaningful equals and hash code implementation, and that is derived from the components. And we can see this in action if I create a second product record here, but I'm giving it exactly the same values for the components. So what I can do now is I can print out the result of a reference comparison between these two objects. And I can at the same time also print a output of calling equals on P1 and P2. Now, if I run this again, then you will see that the first comparison is false because these are two distinct objects in memory. I instantiated two different objects, and that is still something that is not equal to each other here in terms of references. But if I really ask whether this product is equal to the second product, then I get true because every data point, every component is actually equal, which means that it's the same product. And this will always be true because these records are immutable. Now, going back to the record again, in this record, as I said, you cannot extend other classes or other records, but you can implement an interface if you want to by adding an implements clause to the definition. What you can also do is you can add any methods here, but you cannot add fields. So you cannot add state to these kind of records, because that would invalidate the whole immutability of a record, and also it would have additional state rather than the components that are part of the record. So that's just not allowed. What you can do is you can, besides adding methods, also override methods of a record that are otherwise provided. So I could implement my own equals and hash code implementation here if I wanted to. Of course, you would still have to ensure that the semantics of these methods are preserved, but that's something that you can do. You can also override accessors if you want to. But what's more interesting is that we can also provide a constructor, for example, to do validation, because that's often something that you want to do in data classes. So here I can create a product constructor, and then we have two choices. I can either, again, list the components as constructor arguments, which would have to match one for one with what I defined above. But because that's a bit redundant, there's also a new way of doing this, where you leave off the formal parameter list and just provide the body of this constructor. This is a so-called compact constructor for a record. And there we can say if, for example, the price is below 0, and as you can see, we get access to this parameter anyway, even if we don't define it yet in the formal list of the constructor. And let's say that we want to throw an exception here, because we don't want negative prices. That's perfectly possible. And what happens is that the compiler actually inserts the assignments of the parameters, the implicit parameters to this constructor, to the fields of this record. We don't have to do this explicitly. You can see that this works also by, for example, changing this exception into normalization. So let's say if we wanted to normalize the price to 0, if something below 0 was provided, then we can do it like this. And then you can see that this parameter gets overridden, and in the end will also be assigned to the field of price in the record. So this way, we have a very concise manner of implementing validations and normalization for data that gets into a record. Now, going back one more time to the main class, there's one last thing that I want to show, because you cannot just have top-level records in their own source files, as I just shown, but you can also have local records inside of a method. And that can be very convenient if you want to just group some data and give it a meaningful name. So, So let's, for example, say that we want to have a record, discounted product, where we wrap both a product and a Boolean. Let's call the products. We still need to provide a name here, and a Boolean whether it's discounted or not. There we go. And with this definition, we can now immediately start using it inside of this method, where we can instantiate it and print it to the console. So let's create a new discounted product. And again, we get the constructor for free, and we're passing in, for example, product P1, and let's say it's discounted. There we go. If we run this, we will again see that we have a nice toString implementation, which now has another nested record which also works out nicely. So all in all, really nice to work with. And I think records will be a very highly used and anticipated feature for future versions of Java. But we can already do this as of Java 16. Now, where would you typically use records? I think DTOs, so data transfer objects, are a pretty obvious place where this can be really nicely applied. So, for example, in your APIs, where you have classes that represent a JSON that you want to serialize or deserialize. Jackson 2.12 has support for serializing and deserializing records, so that's already possible. Some people are also wondering, can I use records for JPA entities? And that's not really possible because these entities are assumed to be mutable, and there are some other restrictions there. So they're not a great fit for that. But data transfer objects and as part of your API definitions, definitely. Another place where you can very well use records is as map keys. So often you want to have a map key that consists of several data elements together. You would now have to create such a class by hand, but a record definition can be a really light way of creating these kind of compound map keys. So that's another use case where I think records will be used. And then last but not least, there's also the opportunity of returning multiple values from a method by bundling them into a record. There you see again a little bit their comparison to tuples in other languages, where you would just have a tuple that you would return. In Java, you can then easily mimic this by creating a record that has multiple components that you can return from a method. And as you saw, a record is a very lightweight way of defining these kind of combined return values. All right, so that's records. Now, the second feature that I want to highlight is called pattern matching for instance of. And it should be noted that this is a first step towards introducing pattern matching at a much larger scale into the Java language. But this first step is already really interesting to see and to learn about. So before we had pattern matching for instance of, you would typically see code like this, where you had an if and you say, oh, this instance of string. And if that evaluates to true, then the string needs to be, the object needs to be casted to string, and you need to introduce a new variable for that, s in this case, and then you can start using s as a string. Now this is a bit redundant. There's a lot of boilerplate going on here. So what pattern matching, for instance of, adds is that you, rather than just providing a type as parameter to instance of, you can also choose to provide a type pattern. And a type pattern consists of a type and a binding variable. And here, s will be the binding variable. Now what happens is that we still have the object O. We pass it to this instance of check. And if it is indeed an instance of string, then the value of O will be automatically bound to S, and it will be in scope inside of the inside of the if branch, so that we can immediately use it as a string rather than having to cast it first. So it's really nice. And you might be wondering here, what happens if O is already known to be a subtype of string? Well, in that case, the compiler will complain. So if the static type of O is something that is already known to be a subtype, and where we know that this check always succeeds, then it is pretty much flagged by the compiler. But other than that, there are not many caveats to this feature. What is interesting is wonder about this kind of case. So what if we would, for example, negate this this check, where we say, what if not O instance of string s? Where would s then be in scope? And actually, the compiler is really smart about this. And it will notice that if the clause for the if will evaluate to true, then actually there's no string s. But if it evaluates to false, then there will be a string s in the else branch, but not in the original branch of the if. So this is called flow typing or flow scoping, and is a really advanced feature of the Java compiler that nicely restricts the scope of these variables to just what you would expect. Now, as I said, this is a feature that is definitely slated for expansion in newer versions of Java. So what I'm showing here is not part of Java 16, but is a possible future direction for pattern matching. Because you can imagine that these type patterns are not only useful as part of instance of checks, but could also very nicely be used in switches, where a case would not match against a constant, but would match against a type pattern, as is shown here. So there we can see that in this case, we would have a case integer I. And if this case matches, then on the right-hand side of this switch expression, we would immediately be able to use I as an integer without casting it, similar to what we saw for the pattern matching with instance of. Now, the future directions of pattern matching are not just about applying these type patterns in different places, but also about allowing different kinds of patterns to arise in the Java language. For example, in combination with records, which we just saw. What if, for example, we would have a record definition point taking two integers? Then it would be very nice if we could directly match an object against a pattern that checks whether this object is indeed an instance of point. And if that's so, immediately bind the two components to these local variables, to these pattern variables, x and y, so that we can start using them. And we don't have to extract them using the accessor methods. Now, again, this is not in Java 16 yet. This is something that is being worked on currently in OpenJDK, but this is a very likely future direction for this for the pattern matching future to evolve in. Just to give you a bit more taste of what might be coming, you could also think of other patterns, for example, matching against an array pattern, where you say, okay, O might be an array of strings. And if that's the case, and if it has more than two elements, then I would like to extract the first and second element directly as two string variables, S1 and S2. And in this case, the if would match if O contains a string array with more than two elements, it would discard the remaining elements and just bind the first two to string S1 and S2. So I think these are really exciting future developments. But the first step with pattern matching, for instance, of has already been taken in Java 16. All right, that brings us to a final feature that I would like to discuss. And it should be said that this is a preview feature in Java 16, which means that the feature has been deemed almost ready, but not quite final yet. It also means that you will have to add a special flag to the compiler and to the runtime to use this feature. So it's not something that you're supposed to use in production code yet if you're going to Java 16, but it is really meant to use and to explore and to provide feedback to the JDK team on this feature before it becomes final part of the Java language, which will most likely happen in Java 17. With that being said, why would we want sealed classes and what is it? Let's imagine that you're a library author and you want to offer a hierarchy of types with at the top level an option type where you have two subtypes, sum and empty, representing the two states of an option. Now, what you would like to prevent is that there are people who will be adding a third subtype, like for example, maybe, because in this case, it really doesn't make sense. You really want to restrict to an exhaustive list of two options, two subtypes. Option should only have sum and empty as subtypes. Now, there are not really great ways to model this currently in Java. There are some tricks, and I'll show one, but in general, it's not really supported. And if you would make option final, for example, which is the only restriction we currently can place on inheritance, it would mean that there couldn't even be any subclasses of option. So that's definitely not a solution here. So what can you do? Well, before sealed classes, you would be able to do some trickery with a private constructor on option, which prevents any new subclasses to be implemented unless they're in the same source file, unless they're in the same class defined, as is shown here. And this trick sort of works, but it's not really nice, and it's not really revealing the intention of your of why you're doing this. So with sealed classes, we actually get a new keyword that we can use in our class definition, where we say public sealed class option, and then we get a list of permitted subclasses after permits. So we say that sum and empty are allowed to extend this option class, but that also means that no other classes can extend option. And this is exactly what we want to express in this scenario. And then we can just implement empty and sum as final classes that extend option. And that's possible because, well, they're part of the permits list. And there can be no other subclasses of option in this case. So this is the sealed classes are really a way to control an inheritance hierarchy, where you want to have a overview of what subclasses are there and want to be sure that there are no other subclasses. Definitely not something you would use for every inheritance hierarchy, but if you want to have an exhaustive and know upfront which subclasses there are, sealed classes are the way to go. Now, there's a second way in which you can do this without using permits, by saying, okay, I have a sealed class option again, and then any class that is defined in the same source file as option is able to extend as the extend option. And there you don't need a permits list. So this is just an equivalent way of stating the same thing that we saw in the previous example. Okay, so that are sealed classes. That being said, what happens in the various subclasses of a sealed class if it's not fine? So there are a couple of options. If I, for example, create a sealed class vehicle, which permits 3 explicit subclasses, car, plane, and boat, then each of these subclasses still have a choice on whether they themselves are final or not. And what we see here is that if such a subclass like car would be final, then that's the end of the line. There can be no other subclasses of car. And this is all in the clear. What you can also do for a subclass of a sealed class is say that a class is explicitly non-sealed. And then you're opening up whatever comes under this plain class again for subclasses. You still cannot directly extend vehicle because it's sealed, but you can now extend plane if you want to. And then there's the other option, the third option of also declaring your subclass of vehicle to be sealed again. And in that case, that sealed class boat still needs to indicate what permitted subclasses there are. So for example, here we would have 2 with speedboats and steamboats, and these would either be in the permits class, or it would have to be, or those would have to be classes defined in the same source file as we saw previously. Now, sealed classes are really interesting. As I said, they're not final yet, so things might still change a bit. If you're interested in this, there's a Java enhancement proposal at the following URL that you can look at. It contains a lot more details about this feature. Probably in Java 17, this will become part of the real official Java language, so it will be a final feature. But for now, we can already use it as a preview feature in Java 16. All right, and with that, we saw 3 major language features and a small API addition in Java 16. So let's wrap up. But there's much more in Java 16 that we didn't get to yet. There are many more incubating APIs that are introduced into Java 16, mainly about interacting with native memory and with native constructs like factorized APIs. Really interesting developments, but these incubating APIs, again, are not finalized yet. So they're there to gather feedback and to gather real world use, but they're not production ready yet. Still, if you're interested in this space, I highly recommend checking out these APIs. Also at the JVM level, there are a lot of improvements that you can benefit from when you move to Java 16. For example, the ZGC garbage collector, which is an impressive piece of engineering offering really low latency garbage collection, has had some more improvements in Java 16. There are some changes about the metaspace management of the JVM, which goes a bit into the nitty-gritty details. But again, if you want more details, look at the Java enhancement proposals, which you can find through the URL that is on the bottom of this sheet. The other thing I want to highlight is that as of Java 16, a lot of internal APIs are more strongly encapsulated, meaning that access to those will be blocked and will result in errors. And you might be using libraries in your application that are still abusing, I would say, internal APIs. And with Java 16, this becomes more and more of an issue. So definitely something to be aware of. And unfortunately, also a lot of library maintainers are waking up to the fact that these internal APIs are being encapsulated and are being more strongly guarded. So they're moving to public alternatives and really supported alternatives there. So it might very well be that to run on Java 16, you will have to upgrade some of your libraries. One last thing I want to mention that is interesting if you're actually creating distributable packages for desktop users of your application is the new tool called JPackage. This tool allows you to create native installers, for example, MSI and exif files for Windows, or Debian packages or RPMs for Linux, and so on, using this new JPackage tool. Again, there's a JEP for that, which you can find through the URL listed here. And with that, I would like to thank you a lot for joining this session and for taking the time to learn about these new features in Java. If you want, you can also go to my author profile at the bit.ly URL shown here, and you will find a lot of Java courses also around previous versions in Java to see what's new there. I have a course on the HTTP client, for example, that was introduced in Java 11, and a course around the Java module system, which was introduced in Java 9 and has a fairly large impact also on the Java ecosystem, which is also still present in Java 16. So yeah, I highly recommend checking it out if you're interested in learning more about what's happening in Java. And as was said at the beginning of this session, you can do so for free at the moment using Pluralsight's free April. So still 2 weeks to go, I would say. Highly recommend it, and I hope you can find what you're looking for there. And with that, it's time for some Q&A.
Awesome. Thank you, Sander, for that presentation. I know that a lot of good information in there. So first question that we have from Danny, in relation to records, he asked, are multiple constructors supported so that some fields can have default values?
Great question. So what I showed is that you can create a so-called canonical constructor with all the elements that are necessary. You can definitely also provide custom constructors with different arguments, but then you, in the end, would always have to call the canonical constructor as well to ensure that the constructor is initialized correctly. So yes, it's possible, but there's a small restriction there.
Awesome. So a question from Victor, and this might just be a clarifying question, but he said, when you said switch and other pattern matching features are already in OpenJDK, did you mean OpenJDK 16? I thought OpenJDK was always in lockstep with Oracle, and one should be able to switch between the two, assuming same version without issues.
So to start with the latter, yes, indeed, OpenJDK and Oracle JDK are indeed in lockstep. So that's not what I was pointing at with that remark. So what I wanted to point out is that the pattern matching, for instance, of that we discussed is in Java 16, so both in Oracle JDK and in OpenJDK. But the future enhancements, so pattern matching in switches, array patterns, record patterns, these are being developed in OpenJDK, but they're not part of an official release yet. So this is something that is coming up in a future version. But you can already get a peek by either looking at the Java enhancement proposals that are linked, or by just looking at the non-release parts of OpenJDK that are currently being developed.
Awesome. And this is probably a good time to remind people that we will also be making the slides from this available and the on-demand version of this webinar after the event. So whatever you use to register, whatever email you use, it will be sent to you in a day or two after the event is over. So we had one more question from social media. Are there any changes with multi-threaded applications that we should be aware of?
In terms of multi-threading, I'm not aware of any big changes in Java 16. So on that front, I don't think there are any things to be aware of for your applications. No. Okay.
And then a question that I wanted to bring up, Sander, is with Pluralsight having free April and potentially a lot of newer JavaScript learners getting on the platform and exploring the language, is there any advice that you would have for new learners or kind of places that you would recommend that they should start?
Yes, definitely. So if you're new to Java and you want to just learn what's going on in this ecosystem and how to sort of learn the language as well, then I think the Java Fundamentals learning path within Pluralsight is your best bet. This is a learning path that really takes you from zero to being able to write your Java applications and to also know your way around in the Java ecosystem, because it's a pretty large ecosystem in terms of what is possible and what libraries are available. So I would definitely start with the Java Fundamentals learning path, of which the HTTP client course that I'm showing here is also part.
Awesome, thank you. So with that, I think we're pretty much at the end. I just wanted to also give you a chance, Sander, before we end this event. Are there any final takeaways that you would have for people in attendance here?
Yeah, if there's one thing that I would like to have you take away, is that Java is moving at a faster pace than ever. So we see a lot of new features are coming in, even in the non-long-term support releases. I know a lot of the people in the community are currently still on Java 8. So I would really urge you to look beyond that and take advantage of these new features by migrating to a newer version of Java, either to the latest LTS release, which is Java 11, or, and this is definitely what I would recommend when possible, to go to the latest non-LTS release, which at the moment is Java 16, because this really prepares you for what's coming also in September of this year, when we are moving to Java 17, which will be the next long-term supported release. So a progression from Java 8 to 11 to 17 is likely expected in the coming years for lots of companies and teams. And yeah, just by having the knowledge that you have now, I urge you just to stay ahead of this curve.
Awesome. Thank you so much. I wanted to just thank you again, Sander, for taking the time today. And as a final plug for those here today, we do weekly webinars at Pluralsight. To view a calendar of upcoming live events and webinars and demonstrations like the ones that you've heard today, you can go to pluralsight.com/events and see that calendar. We will not have one next Thursday, though, because next Thursday is the 3rd annual Tech Skills Day live stream. So again, you can go register for that at techskillsday.com. We have a great lineup of speakers in technology that are going to be kind of sharing their journeys and kind of how important the power of technology skills are to them. And so, yes, thank you all for attending, and thank you again, Sander.
You're welcome. Thanks for having me.
Okay, goodbye, everyone.